Okay, so in this video here, we're going to be talking about how to find the vertical asymptotes of a rational function. And what you have to remember is that vertical asymptotes are going to be a point on the graph where it's going to be undefined. And when we say undefined, that means we have division by zero. So an easy way to remember this here, when you're dealing with vertical asymptotes, you're looking at what's going to make your denominator zero. Now, to do this, you want to factor everything. So when you're given a rational function, you want to make sure you go ahead and factor both the numerator and denominator and then go from there. So for example, on this problem right here, we're being asked to find the vertical asymptotes. Before I can do that, I have to factor the whole thing. So you have to know how to factor, and if you don't know how to do that, I have videos on factoring using the AC method. I'll go ahead and link them below. But assuming you know how to factor, we're going to factor both the top and the bottom here. So doing the numerator using the AC method, I know that I need two numbers when I multiply that will give me 2, but add up to -3. Well, that's going to be -2 and -1. So when I go ahead and factor that numerator, I get x minus 2, and then I get x minus 1, right? And then I'm going to go ahead and do the denominator. So let me go ahead and do that here. So I need two numbers when I multiply that will give me -3, but add up to -2. So that's going to be -3 and +1. So here I get x minus 3 and then x plus 1, okay? And now I have the whole thing completely factored. So from here, you want to look at the factors on your denominator, okay, right here. And we want to say, okay, what values for x will make this undefined? And it's really simple to figure it out. You're simply going to take your factors, set them equal to 0, and solve. So for example, taking this factor right here, you're going to get x minus 3 equal to 0, okay? And then this factor here will be x plus 1 equal to 0. And when I solve both of them, I get x is equal to 3, okay? And then I get x is equal to -1. And remember, your vertical asymptotes are literally going to be the equation of a vertical line, but that vertical line is imaginary, right? It is a line that the curve is approaching, but not actually touching. So we're actually going to have two vertical imaginary lines here that we call our vertical asymptotes, and they're going to be right here, x equal to 3 and x equal to -1, okay? All right, let's go ahead and try another example. So here's our next example. And again, we want to make sure that we factor everything. And so this one definitely has a lot more factoring involved, and we're going to have to do this in multiple steps. So looking at the numerator, I can go ahead and pull out an x. So I'm going to go ahead and do that. I'm going to pull out an x, and then I'll have x squared minus 4x, and then plus 3, okay? And then working on the denominator, I can go ahead and pull out a -4. So I'm going to pull out a -4. So again, at this point here, I'm just pulling out a greatest common factor, and then from there, I'll go ahead and try to factor, okay? So now I'll have x squared, and then minus x, and then -2, okay? And so now you can see that I have two quadratics. I have this quadratic here, and this quadratic here. We're going to keep factoring them until we finally have the entire rational function factored. So working on the numerator, let's go ahead and scroll down. Again, we're going to use the AC method. So rewriting it, you're going to get x. And now I need two numbers when I multiply. That will give me 3, but add up to -4, okay? So that's going to be -3 and -1. So I get x minus 3 and x minus 1, okay? So now my numerator is factored. Now I can work on the denominator. So let's go ahead and do that. Again, I do have a -4 here that I pulled out. And then factoring my quadratic, again, using the AC method, I need two numbers when I multiply that will give me -2, but add up to -1. Well, that's going to be -2 and +1. So I get here x minus 2, and then x plus 1. And so this is completely factored. And what we can do from here is look at our denominator, and in particular, the factors on our denominator, set them equal to 0 and solve. So remember, -4 is technically a factor. If you set that equal to 0, there's nothing to solve for. You get an untrue statement. This part right here is going to be irrelevant, right? It doesn't help us. But then if I take the other factor, x minus 2, and set it equal to 0, I get x is equal to 2. So there's one vertical asymptote. And then taking the last factor, I get x plus 1 equal to 0. That will give me x is equal to -1. So now I have two vertical asymptotes, right? Here they are. All right, let's go ahead and try two more examples. So here's our next example, and same thing, we want to go ahead and factor. Now, looking at my numerator, I cannot pull out a greatest common factor, but I can use the AC method. So I need two numbers when I multiply, that'll give me 3, but add up to -4. That's going to be x minus 3 and x minus 1, okay? Then looking at my denominator, I can pull out a greatest common factor. I'm going to do this off to the side here. I can pull out a -2, and then I'll have x squared minus 9, okay? And this part right here is going to be a difference of 2 squares. I can go ahead and expand that out. So now I'm going to rewrite the whole thing. So I pulled out a -2, and then applying the difference of 2 squares here and expanding that out, I get x plus 3 and x minus 3. Now this one is very interesting because you actually have a whole. Now a whole is when you have a common factor that's going to cancel out. And what will end up happening as you trace that graph, you'll literally have a point where it will be undefined. And that will be the common factor that you will cancel out, but it will not be a vertical asymptote. So for example, if you look at my denominator right now, you may say that, oh, I can see that you have 2 vertical asymptotes. You have one here and here. And remember, this factor here is irrelevant. We can't solve for anything. So this one's kind of meaningless. But looking at those 2 factors there, you would say, oh, you have 2 vertical asymptotes. But you actually don't because you have a common factor. And that common factor is x minus 3. I can cancel that out here and here. And so that x minus 3, which when you solve it will be x is equal to 3, will actually be a whole, okay? And so that is where your whole will be occurring on that function. Again, if you were to trace it at 3 on the x, you will have a point that is undefined, and we call that a whole. So technically, you only have one vertical asymptote here, because again, when you cancel out that common factor, it turns into a whole, not a vertical asymptote. So my only vertical asymptote here is going to be x plus 3 equal to 0, and when I solve that, I get x is equal to -3. And there it is, okay? All right, let's go ahead and try one more example. Okay, so here's our last example, and looking at my numerator, I cannot factor anything out, so I'm gonna write 1. And then looking at my denominator, I can go ahead and pull out a -3x. So pulling out a -3x, that will leave me with x and then plus 3, okay? And so from here, I can't factor anything else out. So what I'm gonna do, I'm gonna take both my factors right here, I'm going to set them equal to 0, solve, and then I'll have my vertical asymptotes. I'm going to end up having 2 here. So -3x equal to 0. If I solve that, I get x is equal to 0. So there's one vertical asymptote. And then the other one is going to be x plus 3 equal to 0. That will give me x is equal to -3. And here we go. Here's one, and here is the other one. Okay. So that is how you can find the vertical asymptotes of a rational function. So that is it. I hope that you gained something from the video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.